The true power of ngSpice is realized only when we try to make custom models. There are several applications, several occasions where you need to develop models on your own, generic models, models based on physics, so that you can incorporate them in the Spice circuit or Spice netlist and simulate them in ngSpice. For example, you may want to make a model of a DC machine. You may want to make the model of an induction machine. You may want to make the model of a specific IGBT, or you may want to have a bidirectional switch, or you may want to have a device with snubbers and show it as a integrated symbol element in your circuit, and that in a seamless way, when I make the netlist and then simulate it in ngSpice, it should automatically simulate it by directly taking the model from the specific library file to which the symbol is linked. So all this thing should be we should be able to make, and that is what we will look at now to make special custom models of devices. This actually is the one which makes the ngSpice very powerful. We make the model in library files, and we use subcircuit as the template and make the subcircuit models, and we link it to the symbols which we develop. Special symbols need to be developed such that these special components can be called, incorporated into the KiCad schematic, and then after netlisting and then exporting it to ngSpice. ngSpice should be capable of directly referring to the subcircuit models, which were the references of which were embedded in the symbol that was made, and use it for simulation in a seamless way. It should not be that you are tinkering around in the .cir file or tinkering around in the simulation dialog box in the component models and try to keep adjusting. So the thing is that it is not scalable and it is not transferable. But when you make it like a library of models, then these library files can be used by others also. You can offer it as either open source tools or as part of something else that you want to give away to the people who want to use. So this library tools can form a very powerful set of library toolbox that can be used for simulation in the ngSpice environment. So that is what we are going to look at now, and then see how we make the beginning. We shall start with something small. Probably I will take a diode with snubber circuits. That is, you have capacitor and resistor across the diode so that they can be used for high power circuits, power diodes. You can call it as power diodes. And let us make a special symbol for that and incorporate this subcircuit model, and then see how it is called and then how it is used in ngSpice. So then we can graduate to making other models, like models of op-amp. We can make generic model of an op-amp and then associate a symbol and model to that and then call them in ngSpice. So this way we will try to improve our library repository and then use it for simulation in the Spice engine. When we talk about custom modeling, custom components that we wish to model, there are two aspects that we need to address. One is model of the new component or the custom component, and the other one is symbol of this custom component and how it will appear in the schematic, in the KiCad schematic. So the symbol has to be developed in KiCad. The model has to be developed as a library file to be accessible in the Spice environment. And the symbol has to be linked with the model so that it can inform ngSpice to go and look into this model library and extract the model of that particular component from this library and use it in simulation. So this has to be done. So there has to be a linking of these two happening. So the way it will operate is that you have a model. So this will be a sub-circuit model that we will do. Place it in a text file with a .lib extension. And in KiCad, we will have a specific symbol made, and that symbol will be linked with this model file location of this library which contains the model of that special component. Once that is done, when you generate the netlist, the information of this model linked to this symbol is passed on to the netlist. And when that netlist is called in ngSpice, ngSpice knows where to pick or extract the model information directly from the location specified by the netlist and then use it for simulation in ngSpice. So this symbol with the model location linked together forms a custom component which can be a repository, which can be given to others so that they can also use it. Multiple people can use the model that you have developed along with the symbol. So let us see one or two examples how we do that, and then move on to advanced examples much future in the course. Let me now take an example of a power diode. So a power diode consists of a normal diode model, and across the power diode let us have a snubber, a capacitance and a resistor in series like this and connected in shunt across the diode. This is the anode and this is the cathode. We will call this one as capacitor shunt, C shunt. This is the R shunt, and let us number the nodes. This is one node, the anode node 101, let me call that. This is the cathode node, I'll call that one as 102. And then there is another node here, I will call this as 103. Now this forms the circuit for the power diode. It is having three components. One diode, a generic diode, you have a generic capacitance and a generic resistance all connected in this fashion to see that the voltage stresses across the device is reduced, and therefore we have this snubber circuit. Now this should be treated as a single component with anode and a cathode terminal. So as a two terminal single component I want to treat this one. So first let us have a model for this. So in order to have a model, I will open a sub-circuit. So a sub-circuit is a subroutine type of template in Spice which can combine several circuit components in the form of a circuit into a single module. So we will use that sub-circuit template. So the sub-circuit template has this as a reserved keyword sub-circuit, SUBCKT. And now I will describe this netlist in the sub-circuit. Before that, what is the name I want to give for this module? So I will call this one as diode underscore power diode. So therefore diode underscore power. It's a diode and it's for power application. So I will call it as diode underscore power. You can give any name, just something that occurred to me. So I will just put this name in here, PWR, and this is the consolidated device, and it has two nodes through which it can access the external world. 101 and 102. 101 and 102. This is the anode and this is the cathode. So this is how you define this. Now if I say that this is, let us give a name for that one, dx. Now dx is the diode component. It is between 101 and 102. And I will give it some diode model. So I will give it a name, diode model. We will describe that model. Then C is between 101 and 103. And I have to give it some value. I will say 0.01 microfarad. R shunt is between 103 and 102. And I will give it some value, 10K. Now let me define this model, diode model, through a model dot model command. Diode model dot model, diode model. It is a diode, so I will use diode parenthesis, and within the parenthesis probably I can define what is the RS value, so 0.01 ohm, and probably the junction capacitance of maybe 100 PF, something like that one. Let's say I define it like this. This is my power diode, and you have to end the sub-circuit, and there is a specific reserved word to end the sub-circuit, which is dot end S. So this whole thing is the model part. This is the model part of our new component, and this has to be placed within a .lib file, let us say. You also have to have the symbol. So this whole thing should be represented as a symbol. The whole thing will be represented as a diode symbol, and these two are the corresponding terminals brought out to the external world, anode and the cathode. So let's say this symbol should be made and should exist in KiCad. So this is a power diode symbol in KiCad, and we need to link these two. We need to link the symbol and this model code in KiCad such that it can be extracted in ngSpice for simulation purposes. So let us do this. Let's see how we go about doing this. First, let us write .lib file. We will use a .lib file, which is an ASCII text file, and put in this model of a power diode, and then we will make a symbol and then link this up. Okay, this is the process that we will follow for a new custom component. So I have here the project folders. Let me first go into the project folder and let me open a new folder. I will call it models, and this folder, models, which is placed inside a project folder, is supposed to house the all the special or customized device models. And let us introduce here a .lib file, and into that we will write the power diode model. So I have opened a new text document here, and let me first save it. Let me save it into the project folder, and in the project folder we created this models subfolder. I'll go into the model subfolder. It is right now empty, and in that one I will say, so you can give any name. I'll just say LU devices .lib. LU-devices.lib, and I will save it. So you will see here LU-devices.lib is created and it's available in the models subfolder. And into this we write our model. So this is actually an empty file. Let us start writing the model for the power diode. Let me start by having some comment lines. Library of my custom components. name, author, I will write my address also. So after the initial comments, so let me say that diodes. Let me have a section on diodes, could have a section on BJTs, things like that. And I will want to write the model of power diode, dot sub circuit CKT diode power. So this is what we discussed, right? Diode power 101, 102. These are the two nodes. Let me pull out that file where we wrote the model so that it is there alongside. So here it is. So this is the file where we wrote down the model. So let me pull this in. So let us write this. So if you want to put in some comments, it is useful. You can have some comments in there so that you can indicate that this is the anode and this is the cathode. And then DX is the diode 101, 102 diode model. CSH 101, 103, 0.01 microfarad. RSH 103, 102, 10 K. And then let us write the model diode model D RS equals 0.01, junction capacitance equals 100 PL. So something like this, and dot ENDS dot ends. So we are ending the sub circuit here. So we have defined a power diode model with the name diode underscore PWR, and you can call it in any schematic that you want as long as you give the proper path. So now that you have the model, I need to now have a symbol and link that symbol to this particular file. So let us do that. I will save this, save. So now that this is saved, I will close this. And I will also close this, because now I know that in this LU devices.lib I have my diode model. Okay. So now next I come back again here and let me open the KiCad Pro file. Okay. You open this KiCad Pro file. Okay. Let me bring it the center. So here on the right side, you see that there are several editors. We have been dealing mainly with the schematic editor, and now here you go into the symbol editor. So when you click on that symbol editor, I will expand that, and on the left side here, the libraries, these are all libraries, the 4XX library, 74X library, amplifier library. So if you click on this arrow button here, you will see all the different components in the library. But remember, most of the symbols here have footprints, which means that they are more suitable for making the PCB. For simulation, the number of models are less, and then you will have to kind of include the models on your own by taking it from the net or from the website of the company that makes the particular component. So it is what I am right now going to show you is that you try to make your own custom models of the components which are generic in nature, so that you can start using it in any circuit or any system that you are building without worrying that a particular component model is there or not. So let us see how we go about doing this. One can use one of the existing libraries and place a component within the library, but I don't want to do that. I want to have my own library, and within that I will have my own custom components without disturbing the components in the other libraries. See here that the libraries are arranged automatically in kind of an ascending order. So that also gives me a clue that if I have my first letter as a number, and if it is a number 1, it will pop up whenever you open symbol editor. It will pop up at the top, and I know my library is there right at the top, and you can operate on that. So let me go here to the file, add a new library. Okay, so I will click on new library for this project, and I will click OK. So this this thing comes up like this. So let me put it into a folder called symbols. So in the project, let me also have another folder. I'll call it as symbols. Create. So a new folder called symbols is created here, and there I will say I am going to add the following name. I'll say 1 underscore my components, my comps dot KiCad sim. So let's say I will save this. Now you will understand why I have named it as 1 underscore my components. This 1 will make it pop up right at the top of all the libraries, and mine will be the first library that is there when I open the symbol editor, and which is nice for me because I don't have to go in search of my library later on. So append it with this number 1, and you will see that your library at the top. So once you are in this library of yours, you can now add a new symbol. So you can add a new symbol, give a name for the symbol. So I will say it is diode power, and I'll just click OK. Okay, so you will get a screen like this, and this is where you can draw your symbol. So if you are having any letterings, you can shift it to one side, okay, and start drawing. You can use, you see that on the right hand side there are several icons. I can use the straight line, or I can use the polygons, or I can use the arc, the circle, the square. There is a text and text box, then adding the pin. Okay, so these are things that you can do. Maybe I can take a polygon because this is a diode, so I can fix it in this fashion. So let us say that I have this diode which goes in this fashion. Okay, and then I take a straight line. You will see that the cursor aligns to snaps to the nearest grid point. So you should at least have a 50 mm grid, so that you will have compatibility when you are calling it in the schematic. Double click, close that, and then let me have a pin. So I will say that this pin name is anode, pin number is 1, and I will place it here. I also need not call it as an input, so you can double click. So take this mouse cursor, double click on that. I can edit it to passive, keep it passive, that's it. Then I will take one more. Pin name is cathode, let's say it is 2, pin number 2, passive, okay, and I rotate it and then place it here. So anode and cathode. So I can hide them if they want to, hide some of these features so that it doesn't reflect onto the schematic. Okay. I will edit the reference field to be X. For all sub-circuits, the starting letter in SPICE should be X. So it being a sub-circuit model, we know that. So let it be starting with X. And so this is something that we will have it. The KiCad net listing is quite powerful. It can also, looking from the model that it is a sub-circuit, it can prefix X to whatever reference that you give. For example, you can also give something like this. Let's say I give diode D1. So I could give this name. And then later on I will show you that when you run the net listing, it will prefix an X in front of D1. Okay. And before you at the time when you are making this symbol diagram, I want you to go to the preference, have a look at this preferences, click on the preferences and on the grid. So you see that the grids, there are different grid sizes that are indicated. You have to choose the 50 mils grid size, because this is the one which is compatible to the schematic. The positioning will be automatic, and when you are drawing the wire, they will actually lock on, snap onto it. You can choose 10 mil grid for making the symbol, but only at the time of making the symbol. Then you will have to, after you make any specific symbol which needs a higher resolution, go for 10 mils and then again bring back your overall symbol resolution to 50 mils grid and save it in that grid position, so that when you lock the symbol and save it, it should be in the 50 mils grid position. That is important. And if you go here on the top, there is something there, right? There is an icon. It's called the symbol properties. When you click on the symbol properties, so what will pop up is basically the library symbol properties. When you actually double click on the KiCad schematic, this will pop up. Reference value. So right now you give a value of diode PWR. So this is the value that will actually get typed in the net list whenever you call this particular symbol. So this diode PWR will actually reference to our sub-circuit. So give that same name what you have given in the sub-circuit model. That's very important. Then another important point that you need to add is the sim library. What is the library that it should reference? So I can add here sim, first the sim name. So the name is also something which diode PWR. Okay. Then I will also add sim dot library. Now here, this is where I have to give the proper path. It is in models. If I look at the current project directory, in the project directory there is a subfolder called models, and in that one lu devices.lib. So in the lu devices.lib, I know that there is this model existing. So give that, you have to give that name so that we know where it is located. You can hide all these things. You need not make it show up. Hide all these things. Even this can be hidden. Only reference D1 will show up in the schematic. Then you see edit simulation model. So this is where you click. So because I have added models lu devices.lib, it automatically goes there, you see, and the model diode power is chosen. Pin assignments. If you click on pin assignments, you see that these are the pin assignments, mapping and matching, and you see that in the linked model, this model it has extracted and it is showing you that, okay, this is the model that I found there for diode power. So you know that it is correct and you can click OK. So this is OK. Normally all this will get jumbled up like this. They all come to a particular reference point in the symbol editor. You can disentangle them. You need not worry about that. You just have to click on that and disentangle them. And this is something which is, you may do it, you need not do it. And this is okay, all these things comes up. So you can also leave it, just leave it at that. This is okay. One thing is that edit sim library field. Okay, this is symbols is not there. It is just only models.lu.devices. Okay, so this is like as I have shown here. Save it. So in your my components, I have one symbol which is available. You can work on this one. I will also show you when we get to do few more symbols, custom symbols, it will become clear. Now let me save this and close it. I will close this and I will open the KiCad schematic. When I open KiCad schematic, so this is a schematic. On the right side here you see the symbol, add symbol icon. So when I click on that, you see that there is this my components. So there is a new library which has come in. This is the library that I have created. You can always use it in any schematic that you build. So in that one, when I click on diode power, there is this symbol that is shown and click OK. So this comes up. Okay. Now here you see that there are several of these items that I don't want to be displayed. Why do I need this 1 equal to 1001 be displayed, 2 equal to, so the pin 2, this need not be displayed, sub-circuit need not be displayed. So only this D5, this reference value need to be displayed. All else, I don't want it to be displayed, where you can kind of hide them. So let me show you how to clean it up so that your symbol becomes a neat and nice symbol. Therefore, I will now go back to the KiCad project. I'll go back to the symbol editor. I will open it. So you have the symbol editor. I will go to my library which I have created. See that it pops up at the top. I will double click on that. So you have all these things. Go to this symbol properties dialog, the icon. So in the symbol properties icon, if you go down, you will see that sim.device is created, and that is having show the name. I will remove that one. I will hide it. Pins, I don't want it to show up. I will hide that pins. Show pin number, I don't want that. Show pin name, let me close that one also. All this let me close and click OK. Okay. So now it's a cleaned up. So when you actually now call, I will only be seeing a cleaned up. Let me save this and close. Right. So now when I go back into the schematics, I will close this and I will open it again. I will discard these changes. I will open the schematic again. So I have the schematic editor opened and click on add symbol. So when I click on add symbol, my library is showing up and there is this component diode power. And I click on that, see that this is the symbol that shows up. So when I place it here, it is now a very clean image. So let me, for example, in this particular case, let me delete this. Let me delete this and this. And let me replace my symbol which I have done, the custom design diode here. So this I will rotate it, and let's say I'm going to place it here. Okay, before I place, let me delete this wires and I will rewire them. Okay, I will connect it here. I will place 3 more. This is one more which I need to place here. I'll take that. Then I will place D2. Then I will place D3. And let me place one more and I will remove that so that the component numbering is nice. D1, D2, D3, D4. I'll remove this. And I may remove this also. This was I wanted to show to you in the previous example how to introduce non-idealities. Okay, now I'm just only going to place these diodes. So this diode I will place it here. This diode will be placed here. I'll place this diode here. And this diode here. So these are the 4 diodes which I am having, and I will wire it up. Take this and connect it here, and take that and connect it here. Oh. So that is connected, and I will also connect this to this, and here the node. Likewise, I will have to make a node here. So let me do that. And we have our new full wave rectifier circuit with our own custom built diodes. So when I save this, I will save that. I will export the netlist, SPICE netlist, export netlist into fullwave.cir. So let me save that. Right? Now that it is saved, I will go into this folder, fullwaverect.cir. Will double click on that and see the .cir netlist file, circuit file, which contains the netlist also. So in the netlist portion, look at this netlist portion. You see, as I told you, that it is intelligent enough to recognize that the diode models are subcircuit models, and it will prefix X. It will prefix X, indicating to the SPICE engine that this is a subcircuit. So D1, D2, D3, D4 are all prefixed with X. They are subcircuits, and they are all using this model. And where is this model? This model will be searched in this include file, which is ludevices.lib. And in ludevices.lib, what is there? In ludevices.lib, that is full wave rectifier models, ludevices.lib, you will find that the model that we typed is there. So automatic linking. So all you have to do is, from now on, once you have made it, once this symbol is made and linked properly, I can just go here and, like a regular library and regular component, I can click on that and bring it into the schematic. All the linking and the linking to the models will happen in the background automatically. So this way it will ease a lot of your burden when you are doing future circuits. But as you go along, you may have to work once on each customized component in order to make it proper and behave proper. And once you do that, it is available to you for all your future simulations. So this is an example of how you would make a custom diode.